Hello again. This is the second vlog, and first a little update on what we've been working on the last 2 weeks. The main progress has been in implementing a couple of new roguelike features like procedural level generation and the item system and upgrade system, but of course both of those are still very early in work in progress, so it's going to be a couple more weeks until we can show what we've been working on, just to make sure that it looks all nice. Additionally, there's also been progress made on the music. We have our first track for the game ready, and we're going to be sharing it soon on our social media as well, so you can listen to it. And for this actual vlog, we have prepared a little introduction to Unreal Engine Blueprint, just to make sure that everyone is on the same page. We're going to refer to this in the future, just in case any of the more complicated concepts go over your head. You can come back to this video and look at the basics to make sure everything is clear. So this is going to be a two-part series because there's actually quite a lot of stuff to cover, basically everything in Blueprint just compressed into like the smallest form factor possible for you to enjoy. And it's about an hour long in total, so we'll have half an hour this week and then half an hour next week. So with that out of the way, enjoy. So for this week's episode, we're going to cover variables and events, and next week we're going to talk about blueprint communication, blueprint classes, and organization. Alright, so let's get into the variables. First we have a bool, which is basically just a true or false statement. Then we have an integer, which is any whole number, including 0 and negative numbers. Then we have a float, which is any number at all, including decimals. And if in any case you ever forget what a variable contains, like a variable type, what kind of stuff you can input, you can just drag it out and set it. And whatever you can type in there, that's what a variable contains. For example, in the float, right, I'm going to try to type some text, and it just returns it back to 0, because it's not supposed to hold any text. It can just hold numbers. And in the same way, if I try to put in a decimal into an integer, it's just going to reduce it back to a whole number again. Right, next up we have a string, which is basically text. Of course, text also includes numbers, right? It can be any text. And this can be a little bit confusing because if you try to create a variable, you can see this not only string but also name and text. But in most cases in Unreal wants any text to be in the string format. So that's what you'll be using most of the time. Next we have a vector, which is either a location or a direction in space. But really technically it's just x, y, and z coordinates. So a location is quite straightforward, right? Like x10, y15 would be describing something that's at that location. But then you can also use a vector to point in a direction. For example, if I put in 1 in z only, that's basically an arrow that's pointing upwards in space. So vectors are this yellow pin, and sometimes you might have like some trouble converting some data into this yellow pin in Unreal. So what you can do is you can split this into the 3 different numbers. Right now those are floats that I can just hook in here, because a vector basically just is 3 floats combined together. Next up we have a rotator, which again is x, y, z, but in this case you can see if I split it, it's split into roll, pitch, and yaw. And those are in degrees because it's a rotation, right? Because even though a vector can be used to express a rotation, if you want to, let's say, take this vector that's pointing upwards and rotate it to the side by like 5 degrees, that can be a little bit difficult. You can do it with like some math, but it's annoying. So that's why rotators exist, where if you want to just rotate something by 5 degrees, you just increase the rotation by 5 or 10 in this case, and that's it. Very easy to do. But because rotators are basically vectors, just in a different format, it's very easy to just convert one into another. So whatever case you need it, like, it's very easy to convert them. Next up, we have transforms, which is basically just a collection of a location, a rotation, and a scale. So the location is a vector, rotation is a rotator, and then the scale is also a vector, which of course you shouldn't be connecting the same vector into the location and scale, because that's going to make everything scale all over the place. So a transform is usually described to describe like any object in space. Like any object that you have in your game usually has a transform that describes its location, rotation, and scale. Okay, next up we have objects and classes. So this is all math stuff up here, but objects and classes are a little bit different. So an object is basically what the name implies. It's an object in the game. For example, we have a character here. That character is an object. We have another one over there that's also an object. Now, those characters are objects, of course, but every object also has a class. So in this case, the class of this object is third-person character. And the object describes this unique instance of the third-person character, whereas the class is just the overall class of any third-person character. So these two guys, they share the same class, and I could just create another object using this class. Like, I could just spawn another character that would be a new object by using that class. So object references in Unreal are very important. You need to, like, whenever you want to do something to another object in the world, you need a reference to it. And getting a reference to an object can sometimes be quite difficult. So usually it's a good idea to store object references as a variable. But the problem with storing objects as a variable is that, for example, I might store a character in a variable, right? I've found it, I've done something to it, and I'm storing it there in the variable. But maybe this character died, but I have another function that's trying to reference this variable and this object that I've stored in there. But because the character died, this would return an error for me. So for that case, you have a validate, which if you get an object, you can right-click on it and convert to validate get. So in this case, it will see if this, like, if everything is still fine with that object, does it exist? And then if this is true, you can do something with it. If it's not valid, usually you just do nothing. So for the class now, as I just described, right, every object has a class, and you can easily get the class of an object, right? Down here, get class, very simple. And for example, I have a third-person character and I want to create another one. I could get its class. And then using that class, I can construct another object right here. Okay, there's two more variable types that we're going to talk about, which is enums and structures. So enums are quite straightforward and very useful. You can use them to describe a state of something, and this state has to be an exclusive state. So so exclusive means every object can only have one of these things. For example, here I have the item state, which is like every item can be equipped in the inventory or not owned outside of the inventory. every item can only be in one of these states. And that's basically how enums work. And the good thing is, for example, with a character, you might have a lot of states. Like your character could be sitting, walking, jumping, flying, crouching, whatever. So this is a whole bunch of states, and you can use bools to check like every one of those states. But when you have a lot of states, that's going to get very confusing very quickly. So using an enum instead is a lot easier, because as you can see, I can switch my functionality depending on the state of the enum. So for example, I could say for a character, if he's crouching, he's not allowed to open doors. But if he's walking, he can open a door. So for every state that a character could be in, I can connect up different functionality. Last up, we have structures. And structures are basically just a combination of any other type of variable bundled together into one big variable. So you can use this for a lot of complicated variables where you know, oh, these always are combined together. Like for example, item stats. Like you have always an item name and an icon and maybe an amount. You know, these are things that all items share. So you could bundle them up in a structure like this. Again, another thing that's inconvenient is by default you only have this blue pin for structure, which is the combined structure. But again, very easily you can just split it by right-clicking and choosing split struct, and then you have all the variables that are contained within the structure, and you can set them individually. Now for variable types, you have these different variables, and if you click on them, there's this little thing right next to the variable type, and this describes the type of the type. So there are 4 different ones. For bools, there's only 2, but pretty much any other variable has 4 different types that it can be. So single is just one variable. Array is basically a combination, like a group of variables that are distinguished just by a number. Then you have a set and a map. Now I'm just going to quickly go over arrays and maps because those are the most common ones used, except for the single, of course. So an array is really just, in this case, for example, I have objects, right? And I have an array of objects. And this is basically like an assembly. So for example, you could execute a function where you're looking for every character in a level and you want to do something to them. So you execute a function to look for every character, and usually it will return an array of characters where all of the characters are contained. And so then with that array, you can take all the individual data contained in the array and do something to it. In this case, usually you will do a loop, and then for every element in the array, you can execute some functionality, like set a variable or something else. The last thing that I want to talk about is a map. So maps are basically a key, which is one variable, and then a value, which is another variable. So you can map 2 variables to each other, which can be really, really convenient to store a lot of information. I really like to use enums for this, as you can see here. I have an armor type. So you could switch the armor type, and then for each armor type, you can assign a value, for example, a level. In my case, you can level up your armor. So for every armor that you have, there's a level stored. All right, let's talk about events and ticking. So if you create a new blueprint, it will usually look something like this. You have a viewport, you have an event graph, and you have a construction script. And the way that you get your blueprint to do anything is by dragging from a pin, right? So you could say, I don't know, set a variable, right? Now you see there are these little arrows up here, and basically this will never happen unless I plug in this arrow into something. Specifically, it all has to start with an event. So I can chain these together and plug them into each other, and basically this forms like a chain of events that happen, a chain of actions that happen. But if this is not connected to an event in the first place, it will just never happen. So if you create a new actor blueprint, you can see there's already a couple events here. These are like the most common and basic events that you're going to be using all the time, right? Begin plays, when you start playing. Begin overlap, your actor overlaps something else. And event tick. So ticking basically happens every frame. So whatever you're connecting to this is going to be updated every frame, which makes it very expensive. So you have to be careful not to put too much logic behind the tick event. And to make the tick work, you have to enable this setting in a blueprint. It will be enabled by default, right? Start with tick enabled. This is a blessing and a curse, because if you're working with something that can tick, you have some logic connected there. It's nice that it's ticking by default. But if you create a new actor and you don't have anything connected to the tick, but this is still turned on, it will still cost you performance. So it's very important that if you don't have anything connected to your tick, you should turn this off. So the most common things that you do on tick are things like movement, right? If your actor's like walking around, you want the position to be updated every frame. But can also be a lot of other stuff. Important distinction is between the construction script and event begin play, because at first glance they kind of do the same thing. The construction script fires when you play the game at the start, and event begin play also will fire at the start. The only difference is that the construction script is basically being executed in the editor, and you can do things in the construction script, and they will update the way that your actor behaves even inside the editor, even when you are not playing. For example, I have my character here, and I have implemented some functionality to change the color of the character. And as you can see, it's changing the color right there. I'm not even playing. So this is super convenient. But of course, there's a performance impact of the construction script. And the performance impact is not only in the game, but in your editor as well, right? Because it's basically running all the time. So if you have something and it's supposed to start at the start of the game, but it doesn't need to run in the editor, then you should not put it in the construction script. You should put it behind event begin play. There are a couple of other event types. If you just right click and you type in event, you will see there's a lot of events available. So these are not there by default because, you know, there's so many of them and you probably won't use most of them. But there's a couple ones that are very common. For example, input events. So you can, right, you have events for like every key, if you want that. But in my case, I have events, for example, for the input attack, like heavy. So um, whenever you press the attack heavy button, it will do something. And the good thing is, if you change your keybinds, this will still reference it. If you reference the key directly and the user changes their keybinds, you're going to have a problem. If you go to your project settings, and on the left side, under engine, there's input. And here you can very easily create and adjust your key mappings. And this is also very easily adjust. Like if you just have all your key mappings in here, it will be very easy to adjust it afterwards for the user to change their keybinds. Usually everything will be executed in a row, one after another. That's why it looks like a row, right, with these arrows. But you might want things to happen in parallel. For example, if you're using a timeline or a delay or something. So how do you do that? It's quite simple, by creating a custom event. So you can see add custom event, right? You can give it a name. Yeah, usually not mistype it, but who cares? And then once you've created the custom event, you can now call that event right here. So this way, for example, I could create a delay, and then after some time execute some logic while whatever's happening here still is happening. So this way, if I want this delay, and after the delay something is happening over there, all the logic that I want to happen here is not being delayed. I hope you enjoyed this little lecture. Of course, if you want to see more, subscribe to the channel. Next week, we're going to be back for more.